Have you ever needed to manage a computer that wasn't, right there in front of you? Maybe it's a server halfway across the world, or heck, just one in another room. It's an incredibly powerful thing to do, but it is packed with hidden dangers. Every single command you send, every bit of data you move, it could all be just sitting out there in the open. So how do the pros handle this? How do they keep things secure? Well, that's exactly what we're going to break down right now.
So first things first, we need to really get a grip on the fundamental problem we're trying to solve whenever we connect to another machine over a network. I want you to think of a standard network connection kind of like sending a postcard. Your message is just out there. Anybody with the right tools can listen in on your commands, they can grab your data, or even worse, they could intercept and change it while it's on its way. This is a huge, huge security risk, and it's the core problem that we absolutely have to fix.
Okay, so if the connection is basically an open road where anyone can watch, how do we protect our stuff? Well, this is where our hero, the protocol, enters the story. SSH, which stands for Secure Shell.
See, SSH doesn't send postcards. Instead, it builds a private encrypted tunnel between your computer and the server. As you can see right here, everything, and I mean everything that goes through this tunnel is scrambled and protected. Our open postcard is now sealed up inside a locked, armored box.
And this isn't some obscure tool for super specific tasks. Nope, SSH is the absolute backbone for critical everyday work. We're talking about system admins and developers using it for everything from running commands on a server like they're sitting right there, to securely moving files, deploying new apps, and doing all that essential maintenance. It is absolutely fundamental.
Okay, so our communication channel is secure. That's a massive win, for sure. But this brings us to an even more critical question. How does that server on the other end actually know that the person trying to connect is really you, and not some imposter who's found a way into that same secure tunnel?
Right. This whole process of proving you are who you say you are, that's called authentication. And this is where things get really interesting, because a secure tunnel is pretty much useless if you let the wrong person in. So the most important thing becomes, we need a bulletproof way to verify who's knocking at the door.
Now, SSH gives us two main ways to prove our identity. So let's break them both down.
On one hand, you've got your standard password authentication. This is all based on something you know. On the other hand, you have SSH key authentication, which is based on something you have. These are two totally different philosophies for proving you are who you claim to be.
Passwords seem simple enough, right? We use them every day. But they are notoriously weak. They can be guessed by automated programs called brute force attacks that are just trying thousands of combinations a second. SSH keys, though, they're the industry standard for a very good reason. They use some powerful cryptography to prove who you are without ever sending your secret across the network. Let's take a look at how that works.
The whole system works using something called a key pair. First, you've got the private key. Think of this like your personal physical house key. You keep it safe, you never, ever share it. Then you have the public key. This acts like a custom-made lock that only your private key can open. You can put copies of this special lock on any server you want to get into.
So how do the lock and the key actually work together to get you in? Well, it all happens in this lightning-fast, secret exchange that we call the authentication handshake.
It really just boils down to three simple steps. There's the challenge, the proof, and then the verification. Let's walk through exactly how this little dance happens.
First up, the challenge. So when you try to connect, the server finds your public key. That's that special lock you installed earlier. It cooks up a random, secret message and uses your lock to encrypt it. Then it sends this scrambled message over to you. The cool part is, only the person holding the matching private key could possibly unscramble it.
Next, we have the proof. Your SSH client on your machine gets that scrambled message. And here is where the magic happens. It uses your private key to easily decrypt it, revealing the original secret message. It then sends that now unscrambled message back to the server. This is your proof of identity.
And finally, verification. The server gets the response from your client. It compares it to the original random message it created just a few moments ago. If they match up perfectly, the server knows with cryptographic certainty that you have the correct private key. You're in. Access granted.
So after seeing that really elegant and super secure handshake, let's put these two methods side by side and deliver the final verdict. All right, let's just lay it all out. A password, it's based on something you know, which, let's be honest, can be stolen or guessed. A private key, on the other hand, is based on something you have, a physical file that is incredibly difficult to compromise. The verdict here is pretty clear. While passwords might feel convenient, they are just plain vulnerable. Key authentication is the robust, professional standard for a reason.
And with that successful, secure authentication, the door opens. The fully encrypted SSH session starts up, and you are free to run your commands, transfer files, and manage that server with total confidence, knowing your connection is protected from end to end.
So, the crucial point to take away is this. When it comes to securing your infrastructure, the choice isn't really about what's easy. It's about adopting a professional mindset and using the tools that provide real, robust security.
Which really just leaves us with one final thought. You now understand the difference between a simple password and the professional standard of cryptographic keys. So, the question I'll leave you with is, take a look at your own workflows. Are your remote connections truly secure?